guy who runs.
Hello?
Which is like you.
Can everyone hear me?
Learn to code. So that could be something.
How are we all doing tonight? We doing good? Yippee! You guys are much more excited than me. I'm excited. No, I hope you're all doing good tonight. We'll get started here in a few minutes, but first we just want to cover some general announcements. So the first main one, as you can tell, I'm wearing a t-shirt. No t-shirts! Breaking boundaries every day. So we have a very limited supply of these right now. These are intended to be for kind of our initial kind of marketing spree. So we have 15 here, I think, counting out ones for officers. So they'll be up for sale for $20. We'll probably do it towards the end so there's not chaos. If you are interested and aren't able to get one, please let us know because we will be ordering more. It's just we didn't want to get a huge shipment at first without knowing possible numbers and whatnot. So if you like what you see, we'll get more. Don't worry about it. But we will have those available as well as stickers that are $2, I think, and we'll probably roll out with more later. But that's if you want them, you don't have to get them. But next we have something exciting to announce.
Oh yeah. Dude, is this on? Oh no way. So October 2nd, we're gonna be having a guest speaker. His name is Jacob Stone. He is a gameplay programmer at Epic Games. So he's going to be talking about his experience with it in the industry. You'll be able to hear his story, ask him questions at the end and stuff. So if you're interested in that, that's going to be happening October 2nd.
But for tonight, we got a kind of a big workshop ready for y'all. What I will say is if you want to follow along with our Godot portion of the workshop, I would encourage you right now to just go into your web browser, Google Godot, and download that. It's a really small download. It should take a couple seconds. You don't need to install anything except for maybe extract the file. So if you don't have WinRAR, you can download that. But
It's on Steam as well.
it's also on Steam if you want to do that. I prefer getting a download version because it doesn't auto-update, and it could be weird if your software auto-updates and ruins your project. But yeah, I'd go ahead and download that if you're wanting to follow on 101. The workshop will be more, have a lecture portion, but you also go in and we'll kind of go step by step on how to add and implement features. So for now, we'll hand it over to Maverick and Grant for the first segment.
Howdy y'all. This is the Game Dev 101 workshop, me and Maverick. Talking about just kind of general topics, different occupations within the industry and whatnot. A game developer is really anyone who works on a game. So this could be like a voice actor, an artist, a programmer, anyone who works with sound. There are a lot of facets to what goes into a game. So a game developer kind of encompasses a large group of people. So there's a lot of aspects to game design, to game development, the first one being game design. For this club specifically, we encourage members to make design docs, game design docs, to kind of break down different components of their game, kind of break down their gameplay loop and whatnot. There are a bunch of subdisciplines to game design, like level world design, UI, UX. I mentioned the design doc. We encourage you guys to make that. It helps teams kind of stay on the same page. It's also programming. I know a lot of you people are likely programmers coming from computer science. This is great. There's different types of scripting in game engines. So for example, the Unreal, these spheres you see, it's like a node-based scripting system where there's underlying functions. So there's different ways to program. Touches a lot of different types of, a lot of different aspects of game development. We encourage you guys to pick it up as a skill. Even if you guys are new to programming, it's a great place to foster your skills and whatnot. So, the first art slide, 2D art, pretty simple. There's 2D art, also makes animations. It's just a bunch of slides, interpolated together. There's a lot of different disciplines within that. Concept artists, environments, character artists. It's a really old profession. And there's a lot of 2D artists in here, but we're getting more 3D artists. 3D artist is, just you use like Blender or Maya to make 3D surfaces, and you can texture them and sculpt them to make them very unique and high definition. At times it can take a little bit more time than 2D art, but there's some really good 3D artists here that you guys can learn a lot from, so I encourage you guys to get into it. Lastly, there's technical art. You see on the far right, there's this kind of node system that's Unreal's material system. You can make really complex, high definition stuff pretty easily. There's also like animation rigging, shaders, and kind of the, not nuance, but some subdisciplines within technical art that are very interesting to get into. There's also audio. There's some really good audio people here. I'm personally not a great person to ask about this, but if there are audio people within this club, I encourage you guys to stay. There's definitely a need for this. Yeah. Other important aspects are like production managers, directors, quality assurance and media. In this club specifically for game jams and wolf projects, your managers and directors most of the time are just going to be working alongside you as like another student on the project. At least for developing, there's different types of teams. AAA being like the biggest, Epic Games, that type. Indie being the smallest. There's also like AA, which is kind of a neat small group in the middle. What we're doing is personal projects and game jams and wolf projects. So it's usually like less than 10 people. Wolf projects can't get to more than 10 people, but there, as you see, there's so many different professions within the gaming industry. I encourage you guys to find your niche. There's a lot. So for team roles, there's usually a team lead, a director, like a person who manages progress via like a Trello board. There's a lot of programmers and artists depending on the size of the project. The team size varies. Of course, you'll also have writers, audio designers, and musicians. Potentially, depending on what your team needs, you might recruit, people for animation rigging. It really depends on your project. So for scope and scope creep, it's really important to establish a minimum viable product, which is essentially the minimum you want your game to be to play it for you to be satisfied without adding other features. Why we encourage this is because it's very easy to overscope when adding just a few features. This is called scope creep, and it's why we encourage you guys to have like a design doc and break down your game into like a game loop, and give yourself more time than you think it would take to implement whatever feature is really implementing. So communication is also really important. For most of the game jams, we use Discord. We will facilitate Discord channels for most of the game jams that happen for the club. Task boards like Kanban boards, like Trello and whatnot. I know GitHub also has their projects page help, but pure programming and meetings also help move your game jam projects along and are very encouraged.
All right, I'm going to go over some of the tools that we use for both development of software with engines and with art and other aspects of this programming. So first off, game engines, the foundation used for making your games in the first place. There's a variety of options for the industry. There's Unity, Unreal, Godot, GameMaker, RPG Maker, and many more, both popular options and niche options in the communities out there. First off, who here likes Unreal? Raise your hands. We got a few, okay. So Unreal is definitely known for its graphics. It is used by a lot of AAA studios, a few in Raleigh especially here. And it has great scripting, node-based options as mentioned before, and a lot of free assets which are really helpful for aspiring developers. Then there is Unity, which is, while more code-oriented, it is very simple to get into. With a high focus on 2D art, it isn't as prominent in the AAA industry, but it is a great place to learn and definitely work from a starting point. Additionally, as a student, you do have access to this for free, as long as you just sign up for the student plan. Then there's Godot, which we'll go over later today a bit more, which is the easiest to get into. It is open source, very lightweight, easy to work with, and it does, apparently, virtual reality is being supported. That's new for me to see, but really cool resource pool, a lot of great options, and hopefully you all will see a bit more of it today. So then for just general like IDEs with programming, we have Visual Studio Community, just the basic one from Microsoft that you work with. General option for groups like Unity where you just simply just work with code. VS Code is a lighter version of that, and there's additionally Rider, which is free as a student option. And then for source control, we do run a few different options. GitHub is obviously the most popular, which is what people use for just keeping their builds, their versions, and their work all sourced and linked together appropriately. Then for 2D art, there is first traditional 2D, which is more of just, as like the first image there, that like painted, drawn, that artistic style like shown. A very popular tool is Curia, which is, I believe, not free, but there's trials found available, very helpful. I've seen a lot of great work from it in this club. There's also Photoshop, which is free if you're a student. And then for pixel art, there is, not anymore?
I know it's Substance Painter. All the Substance ones are free.
Okay.
I don't know Photoshop is, unfortunately.
I don't believe it is. No, I remember looking into that last year.
It
and
should be.
It should be.
Yeah, it's in the DML. I think you can use it in the DML.
Okay, makes sense. And then for pixel art, we do have Piskel, which is just an online tool. It's very easy to access. If you want something with a little more options and versatility, Sprite is my personal favorite. You can find it on Steam or even build demos online, which is very helpful. There's also MS Paint, and then just, there is no right or wrong. Hey, what?
LibreSpite's also very well.
Oh yeah, true, LibreSpite. And then there is no right or wrong software at the end of the day. Just whatever helps you create your medium, that's what matters, be it animations, art, design. And then there's a 3D aspect as well. There's Blender, which is a very popular one here, and also Autodesk Maya, which I haven't seen as much of it, but it's there as an option.
It's used in the industry.
It is, yeah. But Blender will be our main focus in the club. And then for music and audio, we have a few options there. We've had demos before in LMS, which is where you kind of just drag and drop notes and create different MIDIs. There's Reaper. For music notation, we have MuseScore, which is pretty popular here in the club. I've seen a lot of great work there at game jams. And then for raw audio edits, there's Audacity for sound effects and a few other tweaking here and there. And of course, there's always more options to look into. Feel free to use whatever's works best for you. And we always look forward to seeing what you make here at Sound Design. And then finally, we have production software, which is a bit more for the managerial side. Trello, for example, is a tool for putting out task boards, assigning it to each member, and just tracking progress from start to finish. This is a really good way for people to see who's working on what and how to assign things appropriately, and have a bit more organization to game projects over time. Mira and Jira are both great options there as well, but Trello is definitely the most prominent here in the club, I'd say. And then here's a few resources available in the PowerPoint. Well, there's the link later on today. Just a few videos for some of the engines, some starting points to look into. Feel free to just give them a shot after the meeting and look into whatever strikes your fancy. And then here's a few other readings as well for just documentation, some forums, and asset options. And now I'll have to pass it to Faye for the actual workshop. Yeah, you just speak to that.
Oh, cool. So the tab's already open. Let's see.
Go Godot.
All right, hello. So everyone, I'm Faye. I am an alumni of the VGDC, graduated last year. Was in the club for 3 years. Finally get to do a Godot workshop now right after graduating. So let's get into it a little bit. All right, so what is Godot? So Godot is an open source game engine. You already heard a little bit about it just now from Maverick and Grant. But it was originally released in 2014 and has recently gotten a lot more popular, especially since the Unity debacle that happened last year with the runtime fees, for those who know about that. So Unity, Godot is pretty similar to Unity functionally. It can be used for both 2D and 3D games, and also has its own built-in systems for physics, animation, and shaders. You can program in a few different languages, but the primary one that it uses and that most people will be using is GDScript, which is a language built specifically for Godot. It's Pythonic and uses a lot of the same syntax, and it's made specifically to work with Godot's scene structure. So it's designed for the engine, built around that, built to work with the engine specifically. You can't just make a GDScript file in isolation and try to make it do something. It'll only work with the engine. You can also work in C#, C++, and a few other community-supported languages. Like, you can work in Rust if you want to. I haven't tried it before. You have to go through a little bit of engine compiling to get it to work, but you can if you choose to do Rust or Swift. But GDScript is the main option for programming. So, in the past, Unity and Unreal have been the most commonly used engines. And the VGDC in the past has had workshops on both, mostly Unity, with Unity being the focus as the beginner-friendly game engine. But Godot has gotten a lot more attention recently as an alternative to Unity, especially after the runtime fee thing where they were basically charging developers for having their game being downloaded, which is not the best way to get good PR. And so a lot of people were really upset about that. They rolled some of that back, but anyway, the consequence was that a lot of Unity's community kind of abandoned it in favor for other engines, particularly Godot. So, on top of that reason, and with some recent updates to Godot, the 4.0 update, which has added a lot more, made the engine a lot more robust, added more features, made the 3D stronger, just generally brought it a bit more up to par with the other engines. VGDC has started teaching Godot for some of those reasons. It's also just pretty easy to use generally, pretty quick to learn, to set up, to install. Unity has like a new version that it releases every week or something, and it's completely not compatible with the previous project that you try to import into it. It's a little bit annoying. This you can download in about 30 seconds, and it's like a 200 megabyte download, and then you're done. You can just import something. Plus, it's got a cool little robot guy as a logo that's inside of every project that you create. You get the icon.png, or now known as icon.svg, so that's a nice little perk. So, we are not requiring that you use any particular engine. As mentioned before, you're welcome to use Unreal, or Unity, or GameMaker, or Source, anything you want. You can do it on a TI-84 plus graphing calculator if you want to. It doesn't really matter. If you can make a game out of it, that's fine, whatever you feel like doing. Godot is going to be the focus for workshops, on top of maybe, at least in terms of 2D, and as an intro tool. But you're free to use whatever else you actually want to. Yes, I get to do it. For those who are unfamiliar, this is the Godot Pog PNG, an emote crafted by Max a couple of years ago. It's fantastic. Okay, so to install Godot, you can get it from the website, or you can get the latest version through Steam. Godot will automatically update through Steam, so most recently version 4.3 was released about a few days ago, and it will just automatically update, which can be good or bad. Usually, projects with Godot are fairly compatible with the previous version. There was like one thing that was changed between 2 and 3 with tile maps that's like a little bit weird, but generally there shouldn't be any problems porting it from version to version. So either getting it from the website or from Steam should be fine. If you want to use C# instead of the GDScript language, there is a different version of Godot that you need to download called the .NET version. That one you have to get specifically from the website. If you get the Steam version or just the basic Godot version, that only has GDScript support. So we're going to be later on looking at a sample project in the asset library. If you search for 2D platformer demo, that will be the first result. You can feel free to download Godot. We'll do like a little bit of a demo later, but I'll go through the rest of the slides and we'll come back to that later. So, the asset library, which is mentioned, as soon as you install Godot, there is this little window to the right of projects called the asset library, where you can just type in and look at a bunch of random free projects. You can have templates for things you could build off of, demonstrations of different features, like how to make a 2D platformer, how to make a 3D like first-person shooter, how to make a VR game, just like demonstrating some of the various features that it has through sample projects you can just look at. Most of them are free and under the MIT license. I think all of them in this example are, except for like whatever this is that says unlicensed. Most of them are made by Godot itself, and so you're free to just take them, edit them, copy them, even use them in your own projects if you want to. It's basically free code for taking free assets if you want to use them. So pretty helpful also just for learning how things work and exploring engines and previous projects a bit. If you don't know how to do something, you can take a look at how someone else did it and maybe build your solution around that. So pretty helpful resource. Okay, so on to the actual architecture of Godot. The primary objects that you're working with are called nodes and scenes. Those are the bread and butter of Godot. So everything in Godot is a node. A node is like an individual building block of any other like object that could exist in the world. So these smallest little components, if you use Unity, a component, or Unreal, the equivalent for those in Godot are nodes. It could be a sprite, a collision box, an animation player, a particle effect, could be a mesh, just the smallest piece of function for anything in Godot is a node. The three main categories are Node 2Ds, which are primarily used for any 2D game, Node 3D for 3D games, and then a control, which is mainly used for UI elements, and those are kind of grouped a little bit separately from all other node types in Godot. They are blue, red, and green respectively. Everything in Godot pretty much inherits from the node class, except for like a few edge cases, which are resources we'll talk about later. But generally speaking, everything that you can see in the world is a node, and will inherit from node. So, if a node is the smallest little building block, then a scene is a larger object made up of several different nodes. So nodes have a hierarchy, and you can make a tree out of them. So a single scene might be a list of nodes that make up a larger object that can be instantiated into a game world. So everything that is an object, something that you can create, is a scene, has the file tscn. So you can have, on the left here, a player scene, which has a couple nodes in it, like the basic root node, a sprite, it has like a collision box, an animation player, some sounds, just everything that the player's scene would need has all these individual node children. And on the right here is the level that has the player in it. That is also a scene. So scenes can have other scenes in them. You have, it's like every type of object is a scene, both a level or a player or some specific UI element you have is also a scene. Scenes are made up of nodes, and scenes can have scenes in them and other nodes. All of it is in a tree structure here. So you have your root game node, the game has the level inside it, and the level also has the pause menu inside it, which you can just kind of see there. And in order to make these things work, you can have scripts attached to nodes. This defines the behavior of a node and has the file extension .gd, specifically for GDScript. It works a little bit differently for C#, but we're not going to go over that right now. So scripts control most of the interactions between nodes and scenes, and they make custom functionality for a node. So if you have, say, a character body, which is just the basic controller for a character that you can move around, if you want to have it do anything else other than the default functionality, then you need to add a script to it to tell it how it works. And then any node that has a script can reference any of its children. So the player over here has all these child nodes, like a timer, this platform detector, this sprite. The player's script can reference any of these nodes using the $sign emoji, or not emoji, operator. So a node basically has control over all of its children if it wants to. You don't need to have a script on every single node, but usually in a scene, the root node, which is like the one at the very top, for player, it's that character body, and for the game, it's just this regular node. Those have to have a script on them typically if they want to do anything with their children and like have any functionality that interacts with them to define the behavior of the entire scene. So Godot is very much object-oriented. For any of you who are programmers and are familiar with Java, it's pretty similar to that. In the way that everything in Godot is a node, pretty much everything in Java is an object and inherits somewhere down the line from the object class. So you have these chains of inheritance that basically define what a node is and everything that it can do. So in this little platformer demo that we're going to look at later, there is a coin class that inherits from the area 2D node. Area 2D being a node that's defined in Godot, has like its own chain of inheritance that it is. So like a coin is an area 2D, which is a collision object 2D, which is a node 2D, which is a canvas item, which is a node. It's a whole chain of properties that this thing has. Generally, you don't need to like memorize all of these things. You just kind of need to know what the thing at the top is, what that does, and generally how it works. But it's important to know that this exists so that you can know what properties a node has. So then a coin has all of the properties that a node 2D has, like a transform, a position, and a rotation. Anything that inherits from node 2D will have all of these properties. So anything in the game world, somewhere down the line, will inherit from node 2D. So, in summary, the smallest objects in Godot are nodes, and nodes can be combined into a tree to form scenes, which are the larger objects like a player or a level, or anything made up of several different nodes. Scenes can have both nodes and scenes in them, so you can have a tree full of scenes with other nodes in them. You can give a script to an individual node to define its behavior. Not every node necessarily needs a script, but it's useful for making custom functionality. You can also define a class name at the top of a script. I think that was in this example here, like class name enemy, class name coin. That just means that other scripts, if they refer to it, know that this is a custom type of an area 2D. It's called a coin, not just an area 2D. Yeah. So that's just some of the basics of how things are structured. On to the editor, which is the thing you'll be using most of the time. So when you open up the editor, it will look like this, a completely empty project that has this 3D perspective that you may not even be using, especially if you are making a 2D game. But that's what it will look like as soon as you open it. At the top, there will be 4 different tabs, the 2D tab, 3D tab, script tab, and the asset library tab. If you're working in a 2D game, you'll spend most of your time in the 2D tab. If you're working in a 3D game, you'll spend most of your time in the 3D tab, consequently. Those nodes that we mentioned earlier, like node 2D and node 3D, everything that extends those you can only see in these perspectives. So if you make a bunch of node 2Ds, or like some sprites and some like character body 2Ds, area 2Ds, and then you try to go to the 3D perspective, you won't see them there. Same thing for 3D assets. You will not see them in the 2D perspective. So whichever type of asset you're working with are going to be pretty much completely isolated from each other. And then the script tab is used for editing individual scripts within a scene. So you don't need to install an external text editor if you want to do scripting. All of that can just be inside Godot in the script tab. And then you have the asset library, which the thing we mentioned earlier, it's just a place for you to go look at other random projects, demos, templates, and import those if you want to. It's just a place to look around to get you started. So at the top of the screen in the editor, right below those, there are some settings for how the user interacts with the editor. You can see these in both the 2D and the 3D perspective. Usually, you want to stay in select mode most of the time, which is just the thing that lets you move around your mouse and click on stuff and then say, this is the thing that's selected, I can move it. If you want to move around the editor, you want to hold middle click. So your middle mouse button, your scroll wheel, if you have one, to drag the mouse around, that will pan the camera and move your perspective. If you don't have a middle mouse button, you can instead hold space and left click to move the screen around. And by the way, if you don't have a mouse, strongly recommend you get a mouse for game development. You don't necessarily need that for today because we're just looking around, but it is a very important tool to have. So useful settings include, other than the select mode, move mode. It will just move whatever node is already selected around. Rotate, you will twist a node left and right. Scale mode, make it larger or smaller. Pan mode, you can just left click and drag to move the camera around. And then these are just a couple other settings that you have within the editor when you're moving stuff around. Little edge case shortcuts. By the way, for those who don't know, these slides are available, should be Carson posted in the announcement. So we're not going to go like too in detail into everything right now, but you'll have that as a reference if you want to look back over stuff and find shortcuts and node references. Okay, what? Wait, what? Oh, sorry. My bad. Okay. Okay, so on the right side of the screen, whenever you have a node selected, is the inspector, which shows information about any selected node. You can edit properties of the node here, like the position, scale, visibility, and color. So that thing I mentioned earlier about every node having a chain of inheritance, so you have like your area 2D, which is also a collision object 2D, which is also a node 2D. You can kind of see all of that stuff here. You can see at the top, a coin has all of the properties of area 2D, like the monitoring checkbox, monitorable checkbox, priority, and some other stuff. It also has all the properties of collision object 2D and then node 2D. This is just a way to kind of group all of the properties. Pretty much any 2D node that you'll work with will have this node 2D category at the bottom that has the transform in it. So helpful for understanding what all properties a node will have, and they're kind of grouped by the specific classes that they inherit from. Signals. So next to the inspector, you see the inspector node on the top. There is this node tab, and if you click on signals, it's a separate tab that you can open for messages that a node can emit when a specific event happens. So like if you click a button, it will use the button press signal and then send that signal to something for it to react to it, basically. So maybe you can have a button that sends a signal when it's pressed, and then it can print hi to the console or something. Coin specifically is an area 2D, which has the signal byte entered. If something runs into the coin, it will emit that signal and just tell whatever the signal is connected to that this coin has been touched. So the on-body entered function inside of area 2D is connected there, and it can tell the coin that when it's touched, pick up the coin and make a sound. I don't think it actually stores how many coins you picked up, but it has a signal to connect it to that event. And you can either connect a node to itself, or you can connect it to other nodes to tell them when an event happens. Yeah, resource. This is just a data container that some nodes use for things like collision shapes, textures, meshes, and fonts. These are not nodes, they're specifically just data that a node has. So for example, the coin that we've been looking at, it has a circle collision shape that is just surrounded by it. It tells you how big the coin is if things were to collide with it. If something goes into that blue collision area, then that means it's being collected. And then the file system. So in the lower left corner of the editor, there is the directory that has all code files, scenes, and other assets. There's no real standard way to organize the file system. You can kind of do it however you want a little bit, just because the only thing the project starts with is the project.godot file and then the icon image that's just already in there. So you can kind of organize the files however you want. Typically the way I've done it in the past is to have an assets folder and an SRC folder, with your assets having, you know, all your art or music or fonts or anything created specifically for the project that's not code, and then SRC has all the code in it. You can create subfolders for that. Okay, and then finally at the very bottom of the editor, there is a panel that the things you'll use most often in there are the output and debugger windows. Output contains all of your print statements. So if you have something in your console that says ow anytime you take damage, it will show up there if you have a print statement. Also, sometimes specific errors can pop up there. You can make your own custom print statements or errors to have them print in the output. And then the other main window that you see there is the debugger window, which tracks any errors or warnings that occur in your code. Typically, whenever you run the project, these will pop up here and tell you if something's gone wrong and that you should probably go fix it. So in this example here, there are 2 warnings and an error. These are made custom, so I just had it say, a not so bad warning has occurred. It just at some point randomly when you press the jump button. But usually these will be generated by the editor to tell you if something has gone This window is also useful for if the game crashes, then it will stop wherever you are in your code and tell you what line it crashed on and give you a stack trace, just to help you figure out where the problem was and how you can fix it, what line that happened on. You can also make breakpoints. For those of you who already are familiar with programming, if you're not, you'll learn about that later. But it helps you stop at some point in the code to see what's happening and look at all the variables and values that things have at the time. Okay, so brief bit on scripting. So GDScript is Pythonic, as mentioned before. So if you know Python, this should be pretty familiar to you. It's not exactly the same, but they are pretty similar. GDScript is dynamically typed, meaning that you can make a variable and just call it A, and then it can have any value you want. It could have a 2, it could have the string bread, it could have some other class, it could have a node reference to it. Generally, you can assign it to whatever you want. But you can make it statically typed if you choose to. So you can define, for example, this damage at the top has the colon and then float, which is telling it this should always be a float. But you don't have to do that. It's kind of your choice to say, this variable should always be this type. And then Google Slides is not exactly the best way to learn how to program. So this is just a reference for kind of what GDScript looks like. An example file. Got some, class declaration, variables all declared using the var word. Functions use the func keyword. That's generally what things look like. There's also a few built-in functions. Ready is a function called once when the node first enters the world. It's the same as start if you've used Unity. And then process runs every frame for code that needs to run continuously. The init function is also a built-in function that won't be there at the start of the script, but as soon as the node created, before it enters the world, that will be called. And then the input function helps to process input. Okay, so this is a very cool resource for if you are trying to learn GDScript. There is an online module that you can, that basically just is a self-guided tutorial on learning a bunch of the properties for it. You can find it. It's made by GDQuest, which is just an open source company that makes a bunch of Godot tutorials and resources and stuff. It's very nice. You have this list of lessons that you can go to. It has the GDQuest boy here, and you can type in this little code editor thing to make the GDQuest boy do things. And it just is a follow-along little tutorial for learning a lot of the syntax, how things interact with each other, and you don't need to go into it with any prior programming knowledge or Godot knowledge generally. So if you want to take a look at this, it's listed on the Godot doc somewhere, and then also in the slides. Okay, we're going to run through these pretty quick. This is just sort of a reference for some important nodes that you might want to refer to later. You can look back on this if you want to know what things do, but. So, Sprite 2D. This has a texture. So if you ever need something like a pixel or coin or a texture for a player, you put it in a Sprite 2D. You can set a number of frames for it, so you can import an entire sheet. And then set the number of H frames and V frames to make it animate. So for the coin, it has an entire sprite sheet of it spinning. Animation player is how you control anything that animates. Useful for animating anything, not just the frame of an animation, but also excuse me, things like position, scale, color, visibility. You can animate anything. So probably one of the most important nodes generally in Godot. Collision shape 2D helps to define the bounds of an object. So for a coin, it has this circle collision shape, which just says if you overlap with this, then you can collect it. This is also used for everything like a player or a platform. Anything that has collision has a collision shape. You can also have slightly more complex shapes with the collision polygon 2D. So it can be things other than a box or a circle. You could have it be a triangle or a star shape if you want. So a collision layer. You can control what a particular object collides with through the layer system. So you might not want a coin to collide with enemies, or you might not want the player to collide with some background objects that are on their own unique layer. So you can you can control what interacts with what using collision layers. There, in the example demo, there are 5 layers for the player, enemies, coins, platforms, and ground. The player is on the player layer, which means the layer bit is set to 1, and the player collides with everything else. So the mask bit is set to the other 4. So area 2D, as mentioned before with the coin, it's just something that overlaps and then does something. So a coin can detect when something enters the coin and will emit a signal to tell it this coin has been picked up, it should be collected, it should play the sound. Area 2Ds are not affected by physics, so they shouldn't be used necessarily for things like players or enemies or something that should be affected by physics. Character body 2D is typically what you would want to use for a player character, particularly in a platformer or a top-down game or anything like that. They are controlled via code, usually Korean inputs. You can use them for both players or enemies or anything that's controlled through code and not through the built-in physics system. So you have to define your own custom rules for how it moves, basically. And it uses the physics process loop to make sure that it runs only on every physics frame. Rigid Body 2D uses the built-in physics system. If you just drop a Rigid Body 2D into the world, it will immediately fall because it's affected by gravity. You don't want to manually edit things like the velocity and the position for that. You would apply forces to it. Static Body 2D is just some object that is static in the world. Could be like a platform or a wall or something that doesn't move. Animatable Body 2D is a variant of that. Typically, if you want to move it through animation, you would use that. Tile map is typically used for pixel art games or anything where you want to easily create a bunch of levels for it. You can just drag and drop individual little tiles. And you can combine collision shapes for it, nav meshes, other custom data for each tile. Very nice for making a bunch of levels. And then Audio Stream Player is useful for music or sound or any kind of audio generally. You have regular Audio Stream Player, which just plays it independently of whatever your location is, and the Audio Stream Player 2D, which plays it in spatial sound. So if you want to make it sound like something in the distance, you can have a spatial sound off over in another place, and then it will play the sound differently relative to where the player is. There are also some parts of the audio that are being specifically controlled by the file itself, like whether it loops. So you might notice on the Audio Stream Player, there's not like a loop checkbox. You just have to do that on the file itself. So 3D nodes. Godot has an equivalent version of all of these nodes for 3D. There's a Sprite 3D, an Area 3D, Collision Shape 3D, a Grid Map, which is a 3D tile map. And a lot of the rules end up being the same. You just have to use vector 3 coordinates rather than vector 2. So it's one extra dimension that you have to think about. But a lot of the properties are the same, which is pretty nice for just directly translating. You also have to worry about lighting, especially for 3D, which oftentimes isn't a thing for 2D, especially if you're working with pixel art. But it's pretty important for working in any 3D game. And then UI nodes, which is an entire other category, all of which are green, which are attached to a canvas layer, a unique node for rendering something on the screen rather than within the world. There are a lot of different UI nodes in Godot, so just a couple of the ones you'd be using often are control, texture rect, color rect, a button, a label, and an HBox, which are just specific to setting up a UI, setting up a menu. All of these are fairly useful. Okay, so not to keep ranting at you for too long, move on to a couple resources for how to learn some of the stuff on your own time. So, the documentation is probably the most useful thing, resource that you can use. It just has a reference on every single node in Godot, pretty much anything you would want to learn, a bunch of different tutorials on how to set up a simple project. Your first 2D game tutorial is pretty useful for just getting familiar with the basics. And there's a lot of other guides on specific things like lighting, how to work with tile maps, how to make your first animation, how to work with physics. It just has a bunch of resources for learning each of these new tools. Here you go. GD Quest. So they have a lot of different tutorials, videos and other written tutorials. And basically for any type of simple game that you want to make, there will be a GD Quest tutorial for it. And they have, as mentioned before, this learned from GD Script from Zero tutorial, where it just teaches you all of GD Script, basically, all of the basics that you would need to know in a little interactive tutorial that's just on web. There's also an interactive tutorial, which is a project that you can import. It has these little pop-ups that just tell you to try different things, look around the editor, and just teaches you generally where things are. So, generally, they have a lot of really good resources for learning how things work. Also, fun fact, Godot has a web version, so you can play this on your browser if you want to. It is installable, but if for whatever reason you're on a Chromebook or something and you can't actually install Godot, you can still use it. It has a few limitations like no debugging and you can't export a project, but you could still create a project on web and then download the file, put it on like some other computer briefly just to export it, and then you basically are able to make a full game on web if you want to. Also, you can run it on Android, which is kind of fun, if you want to do game development on your phone, which I would not recommend it, but it is an option. Okay, I don't know why that's an animation. But yeah, these are a few other useful tutorials. Heartbeast, in particular, the Godot Action RPG series, is a very good tutorial for learning a lot of the basics. He teaches you a lot about a lot of these things, applicably. Just generally a pretty good tutorial maker. And then these other two, Kids Can Code and Board and CG, I've used a good bit. They have a lot of good tutorials. In particular, Board and CG, if you're interested in 3D, goes through a simple 3D platformer. Also, Brackeys, for those who are familiar. He, a while ago, was like the guy for making game dev tutorials, particularly in Unity. Like one of the most ubiquitous tutorial creators. He did all of those in Unity, and just recently, like a month ago, started releasing tutorials for Godot. And they're pretty good. He only has 2 of them so far, but they are solid introductions. Okay, so enough of me ranting. We're going to go through some of the editor. So if you haven't already, make sure to go ahead and install Godot from the website, or you can get the latest version through Steam if you have that. And then go ahead and type in this 2D platformer demo and get that imported into the project, which you can find in the asset library. And then did you want to get the stream set up?
Stream, yeah.
So I'll give you a few minutes to do that.
Sorry, I'll bring it back up in a sec. Yeah. Also, we're going to be coming around setting up some power strips, because I know the power situation in here is a little tight. A stream? We're doing stream. It's a good stream.
You're just trying to set up.
I was gonna say,
I didn't.
I haven't just
I played Adventure Comics and Adventure Comics.
Yeah, so sort of like that, but with a big emphasis on revealing new stuff. So yeah, really similar. Have you played Candy Bus? Yeah. It's browser based.
I don't know exactly who wants. Let's keep everyone else. So,
Very good as well.
yeah, I mean,
the
like,
website,
well,
kind of like Nitro, other host sites that you can just play a bunch of those.
I think the main thing is
That's what I was trying to do. That. Yeah. Yeah, let's do that. Who is in charge? Like, who is having laptop dying and is in need of an extension cord brought to their area?
I didn't need to be on the computer anyway.
Yay, just a couple.
I'm not a priority here because I'm not following the thing. It's not what
I just downloaded it anyway, just take a look at it, see what's in here.
Yeah, do that.
Is there an outlet on that middle one? Yeah.
So what is this?
So like, it's like
Fake crypto, that's funny.
which I mean, it's better than real crypto.
It is better. Is it like a commentary on the crypto?
No, I think it's just like number go up.
There's always this game I remember from my game studies class. It was a McDonald's game, browser game. You had to manage four screens to make McDonald's run. And the goal was to see how the goal was showing how complicated the machine was.
Okay, is anyone actually?
I ended up using it.
that's where I was.
I mean, the time management games are tough. Do you think the point was to lose, or was it more so just really hard?
The point was to see. It may be unsustainability, especially if maybe one person at a time, because you're not going to be able to do it forever. You have to act. It's not. You have to actively click on it to make it work.
Yeah.
So perhaps part of the point is unsustainability because of its participation. And things can scale. Like things can go to hand pretty quickly if you're not looking at everything.
Yeah. Scaling is a big part of this kind of game. It can be fun. It can also be turned against others.
They don't really separate their scripts in this demo. There's a script.
That's gonna be a question.
I'm trying to move the 2D. I thought it would be the right click, but right click just gives me this. Add note here. It works like one.
Then we have the selection. The one to the right of it is
But then that's moving down.
All right, so
so if you want to use the entire thing,
if you haven't already, go ahead and import the project. If you haven't done so already, you can just go to this Asset Library tab over here and then type in 2D platformer demo.
Okay, that's
So I can type.
trackpad, so I can't. Let me,
You have to click the Go Online button.
I don't like
But
if
yeah.
you're using 3D. See, they're right
Yeah.
yeah.
That was fine.
Look at my shirt.
When in doubt, Google it. Like 2D camera and no, it's just like what's going on. Literally, try.
I don't think this does work. Well, whatever.
Down with both fingers seems to do that.
There you go. Yeah, it's not ideal. Since you're doing the tutorial now.
I was following along, and I know now we're at the point where you can kind of check it out.
I destroyed this.
It goes up to 4. So you got.
Okay, yeah, it's in the 3D perspective. So, by default, when you open the project, I don't think this is actually working.
What, this? You want to say so?
Alright, testing.
Get loud.
Get loud. Alright, so we're looking at the 2D perspective now. You won't see any of this in the 3D scene as mentioned before because all of these are 2D nodes, so you just have this completely empty void over here, which you might see when you first open the project, but it is there. You just have to click on the 2D tab. So if we run this little demo project, we have this little guy. That is the that's a Shovel Knight noise right there. When you pick up that coin.
Source.
You have this little guy, can jump around, do a double jump, shoot these bullets. You have these enemies that aren't actually particularly threatening because they can't hurt you. They just kind of push you around a little bit. You can shoot them.
Can they fall in love?
I believe perhaps the villain in this story.
Ooh,
You have
that'd
these
be
moving
interesting.
platforms that will bring you up. Just kind of push you a little bit if you get out of the way. Let's see, I don't think you can go out of bounds here. I haven't tried too hard.
How's the clouds on this one?
So yeah, just a pretty simple platformer demo. It's got running, jumping, picking up coins that don't do anything, fighting enemies that can't hurt you. It's got everything, right? So, if we want to look around at some of the internals for this, so we have this base game node, which is just this is the default scene that the game runs when you actually play it. As mentioned, everything is a scene, including the player and all of the levels. One of them has to be the scene that you run. So we have this let's see, I think it's game split screen? No, game single player.tscm, which has this file that's saved over here. Yeah, this one. This is the file that's actually run when you boot up the game. It has all of this inside it. Anything that's a .tscm file is a scene. So on top of that, it has a level, which is another scene. If you click on this little clipboard, then you can open it up in a new tab. So the level has a bunch of stuff in it. It has all of these tiles, which if you go over here and you click on it, you can like paint tiles, add more stuff to it if you want. Draw, add stuff to the world, make it your own and all that. We're not going to do that right now. All of the grass is individually placed here. I don't know how it's ordering them, why it's G1, then 58, then 63. I'm not going to worry about that. But they're all grouped under this grass node, and you can just minimize that. This is just a base node, which in this case is pretty much just being used as a container to hold all of this. And you can like minimize it, drop it down, or expand it to show all the grass inside of it. Same thing with all the flower. These are just decorations. You can press F on anything to focus on it. Just a bunch of little flowers meticulously placed there. And then we have these coins. These coins are also grouped together under nodes. So the coins can be moved individually using the move tool here. Or if you just are in select mode, you can still click and drag them. There's also a few other modes like rotate or scale. Good stuff. You can also move the entire category. So these nodes are together here. If you control click and then go to the move tool, we can move all of them together. If we grab its parent and we move that, which is just this node 2D, that also moves all of them together. So if you move a parent, all of its children's position are relative to that parent. So in the same way, we could also grab the entire level and move that around if we want to. Let's see here. There are also a couple of these platforms. Like this one here, and then this other platform over here, both of which are moving. If we click on the little scene icon here, we can open up the platform and just see its internals over here. Platform has also a bunch of little grass that's meticulously placed there to make it look nice. And then it's got a collision shape, which defines the boundaries of it. Tells you if you run into it, you will hit the platform here where it's touching. And then you got the basic sprite to it, which is just the actual platform without all the grass and flowers on top of it. This is an animatable body 2D. So an animatable body 2D is usually like a wall or a platform or something that's meant to be animated or move around a bit. So if we go back to the level, these platforms, like this one over here, are being controlled by an animation player. So when you click on an animation player, this little window at the bottom pops up, the animation tab. You can use this to add, delete, or edit any existing animations or create new animations. You can add keyframes to it. So animations aren't just for controlling the visuals of something. In this case, it's controlling the position of this platform. So if we play this, it moves it up and back down. There's a little shifted there because I think I moved it at first, but the animation reset its position. We can watch it go up, go down, and loop there. If we want to, we can also do some other funky stuff here. Like we could make it, after 1 second, we're going to turn this blue. We're going to hear it change the modulate. Now it's blue. I actually have to save the keyframe there. And then after, once it gets to 2 seconds, or sure, 2.033, that's fine. Turn back to the normal color. And then we can play this. And see it just like gradually fade between blue and white there. You can animate a bunch of different stuff. So it's not just, if we look at the coin, for instance, over here, and then click on its animation player. All that does is make it spin. I wouldn't quite call that a spin, it's more of like a little wobble. It's not like spinning all the way, but whatever. Yeah, it's just changing the frame of it. That is also an animation controlled by the animation player. It also has this little picked animation, makes it go up. So it's doing a couple things here. It's changing the frame from this to this, and then gradually changing the modulate, which is the color there, to make it transparent over time, make it fade out. And it's changing the position here to make it go up. It's also doing a few other things like calling a function, changing the monitoring box, which is a part of Area 2D to let it know that it can be picked up, or it can be collided with. And it plays this sound here. which is the one that they stole from Shovel Knight, or is the free sound effect that both Shovel Knight and this uses. Probably the latter. So animation players, very cool, very useful. You can do a lot with them. We can also look at some other stuff for coin. So it is a basic area 2D, which, as mentioned, it will detect collisions, but it doesn't stop things from moving through it. So it's got this this list of signals: area entered, area exited, body entered, body exited. Effectively, what these do is they track whenever something touches it. So it has this body entered signal that's connected to this function. And then this is a really, really simple script. All this does is it says whenever this body entered signal is called, it'll call this function, which will play that pickup animation and then emit the coin collected signal. So it goes over to the player and then emits this signal, which will do something depending on what the player signal is connected to. But this is a pretty simple example of the script, just of what a signal is, how an area 2D works. You just walk into the signal and it does this. We can also make it do something else if we want. We can make it print hello. And it will print hello whenever you touch a coin. This is good game design right here. Alright. We can also do some fun stuff like, what if we took the body and deleted it? So QFree is the function you call to delete something. So this would make it so body presumably is the player that touched it. So we would delete the player as soon as they touched the coin. Let's see what this does.
I love coin that kills you.
Yeah. So it didn't crash the game. It just kind of got rid of the player, and the player had the camera attached to it. So it just kind of defaulted the camera location in the middle of the screen, I guess. Anyway, that's good game design right there.
Faye, did you leave it in?
What? Oh no, I got rid of it.
Okay. For a second, I thought we were gonna get jump scared by another player kill.
Yeah. Also, oh, I guess I left the turning green in the animation here.
It's peak.
It's peak?
It's
Should you
peak.
keep it? Okay.
Yeah, I think so.
Why is it over here now? Strange. Oh, okay.
Oh, I think you may have reset it to the reset position.
Interesting.
It's unclear.
Yeah, why? I don't think I did that.
It could be, yeah, no, it's like that for me. I didn't even change it.
That's strange.
I think it's just a bug in the thing.
Okay, this is a problem with the demo project apparently. They didn't look at, but not our problem, I guess. Anyway, these are cool because this is a moving platform. This has no code attached to it. If you go to the platform script, there is no script attached to it. So this is controlled entirely through animation. You can make it do that. You can make it turn green. You can make it spin if we want. Like go over here, take the platform, take the rotation, then maybe go over to right here. Let's say 360. Here we go. Add a keyframe, and then play. Ah, perfect. This is how moving platforms were meant to be. Alright, we're just going to leave that going. So let's take a look at one of these enemies. Ah yes, enemy 2, enemy 3, and enemy 4. Where is the elusive enemy 1?
Perhaps the real enemy one is man.
I'm going to minimize this just because there are a lot of things open.
The layer is actually enemy one is player two.
Oh yeah, the player is one of the enemies. They just don't exist in the level yet.
Love that.
Alright. So you can click again on this little clipboard to open up the enemy in its own little window. You can see, what is this guy made of? So, the enemy is a character body 2D, which is, as mentioned, a physics body that is controlled via code. So it is intended to move, but it's not affected by physics directly. So the movement that it has is controlled by whatever you tell it to do. So if we look at this, oh, wrong script. We're over here. So we have some stuff at the top. Class name enemy extends character body 2D. The top of every script is going to have the text extends and then whatever node it is. So coin has, I don't know why it's not popping up the script then. Extends area 2D because that's what it is. The level doesn't have a script. Let's see, game does. Game extends node. So whatever type of node it is, it will say extends that. Yeah?
You extend more than one type.
No, you can't. So, well, I mean, okay. That's just kind of how inheritance works. This is not an interface. Okay, unless you're C++, because that does let you do multiple inheritance, but that's weird.
If you want to inherit two things, just extend.
In my opinion, multiple inheritance is bad design.
That's great.
Anyway,
I love C++.
no, everything can only inherit one node type. This just tells it directly what it is. So, an enemy is a character body 2D, but really it's its own custom node type that extends character body 2D. Because character body 2D extends collision object 2D, which extends node 2D, which extends everything else. So enemy is kind of just like your iteration off of character body 2D. It's another layer removed. We can even add variables to it that are unique here. So I'm going to edit the code a little bit. Export var useless color. I'm going to make this a color. So now we have a unique parameter to enemy, which is a useless color that does nothing. We can make it red. Wow. Yeah. We have declared red to be the most useless color, apparently, which that feels wrong as an NC state. So why don't we change it to a more appropriate? Hold on a sec. Yeah. Okay, what is the shade? There we go.
My mother went to UNC.
There we go. All right. All right.
I know.
Anyway, so anything that you define in player that's an export variable will show up here on the right. So this is a property that's unique to enemy that not all character bodies will have. Only the enemy class will. You also have some stuff like on-ready variables. All these are referring to the children of enemy here. All the other nodes that are attached to it, like this platform detector, it's referring to this. It has a little $sign syntax, and then it's saying it's a raycast 2D, which, not to go over specifically what that does, it's kind of just like a beam that collides with one single thing, and then says whether it's colliding or not. Excuse me. It also has references to its animation player, its sprite, and anything else that might need a reference in the script. You don't necessarily need to set up the references like this. You can always just say $sign and then whatever the thing is. But it's a good practice to have a list at the top of just any variables that you're going to be using that's a reference to any child nodes. There's also a few things here like sound effects. This is the hit sound effect. We can play it over here. Whenever these guys die, they make that sound. Whenever they blow up, they make this sound. What is this? CPU particles. Oh yeah. This is a particle that they emit whenever they get hit. I don't know if we can... Yeah, alright. Whenever they get hit, they make this little effect. I think this is this is the same texture as the bullet. It just kind of takes that and then turns it into a little effect that they get hit by, but it makes it look cool. Through some little parameters that they're tweaking here. So I've not messed with particle systems too much before, but they're cool. It's taking like 32 of these and generating them. We can make just one. Looks a little bit less interesting. And add like 200 of them. There we go. Let's go back to 20 or whatever it was. We can also change the collision shape of this guy. So this defines the bounds of the enemy. If we were to make this way smaller, like this, and then we were to play the game, I believe they would like partially fall through the floor. Yeah, there we go. We can go in here and turn on visible collision shapes real quick. Yep, and we can see the player's collider is this box here. The collision for all of the platform and the worlds here. Collision for, oh, why is that platform not spinning? It should be. Anyway.
Did you save the file?
What's that?
Did you save the file as changes?
I might not have saved
Oh
it.
yeah, you gotta save.
That's probably it. But you can see they're partially falling through the floor there because their collision shape is smaller. We can also make it much larger, then they'll be colliding with the floor and probably be pushed out a little bit. Yep, and so now they're higher to the ground. We can make them very long if we want to, but we'll leave it like that. So currently these guys can't actually hurt the player at all, which in my opinion is bad game design. So why don't we give them the ability to attack the player? So what I'm going to do is make an area 2D and then add a collision shape to it to let it know what the boundaries of its hitbox are. And then make it, let's just say, a big circle. It surrounds this guy. If the player touches that, then they get hurt. We're going to make it way too large just for testing purposes. So if you get anywhere near this guy, you just get hurt. We're going to call this hitbox. So we can demonstrate a little bit of how signals work here. We had the coin before, which had the on body entered, you picked up the coin. We can do the same thing for this enemy's hitbox. We can say body entered and connect it. And it generated this new function over here. So we get to say if body is player, because we don't want this to collide with anything other than the player. And then go over to the collision here and make sure this only collides with the player and not with anything else. So if it's the player, why don't we just kill it? That's how you test things, is by killing them. Anyway. So now if we walk into this, oh wait, okay. So we deleted the wrong thing there. So this is why you have testing. So queue-free. If you call queue-free just on its own, it will delete whatever that's attached to. What we need to do is body.queueFree. There we go. So now we have a balanced game, where if you run anywhere near the enemy, you die. Perfect. But you can shoot them. But our game also has a fun little bug. The death box is still active after you kill them, so you can shoot them, and then walk into it and die, of course. Which we don't want that, right? So, go over to the destroy animation over here. Anyway, we're going to go over here and we're going to disable this. So go over to hitbox. By default, monitoring will be on. We're going to turn it off. Okay. Oop. Actually, why don't we just disable the collision shape here? So if you check this box, it turns gray, which means the hitbox, or like the collision shape here, is disabled. So we make a keyframe here. By default, it's on. When it gets destroyed, this should turn off. Now it can't kill us as soon as it's dead, which is better game design. Oh. Why is it not hurting me anymore? Hold on a sec. Oh, I turned these off, that's why.
Well.
It's always the thing it needs factor.
Yeah. bad thing when the enemy can't kill you. There we go.
There we go.
Okay, so that's the enemy. See, one other important component in this level I don't think we've looked at yet is the player, which is where? Oh, there are two of them because this is the split screen version. If I run this, no, we have two guys, and they still both die. Yeah.
Yeah.
All right, I'm gonna turn off. I'm gonna turn this off for now. They can't hurt us anymore. Okay. Anyway, so the player. You can click on the clipboard here to take a look at the player scene. They have a lot of child nodes attached to them. So the first one we'll notice here is their sprite. If we look at the texture, it's very long. It's like a whole grid of player textures that has their entire set of animations to them, which are controlled by the animation player. They have a lot of animations like the idle. They're just kind of standing there and moving the shoulders a little bit. There's the jumping, which is just one single frame. The run, pretty smooth. So most of the player's animations here are just their sprite, which is going to be the main thing that you'll use animation players for, is just for controlling what frame of a sprite that it's on. It can do a lot of other things, but this is the most common thing. And anytime you make a player, if they have a list of animations they can control, you'll probably want to do it with an animation player. Player also has, they have their jump sound effect. You can play that. Pretty good. And UI, left, right. I think that these are mobile controls. So this project is, I guess, mobile compatible. So if you want to export it to Android or iOS, you can. That's something I guess I forgot to mention. Some of the export settings. So by default, there's support for just Windows, Mac OS, Linux, and then mobile as well as web. That's specifically if you're in compatibility mode. So there are also a couple other kinds. There's forward plus and mobile. Generally, forward plus is what you want to use if you have some high-intensity 3D application that needs more processing power. Compatibility is what you want to use if you want to export for web or for mobile. Well, mobile you can also use for mobile, but compatibility mainly for web. And generally, it's a good default if you're not expecting to run anything too high performance. So we can look at the player's code here by clicking on the little script icon. So they have their class name defined, extends character body 2D, because again, the character is controlled via code. Some constants, some references to all the node children, and then they have this action suffix, which is specifically for multiplayer. This is like the export variable that you can edit here. If we look over here, we have the P1 and P2, which is just to tell it what texture it should have for the player. So, one of the functions that a character body 2D will always use is physics process, which is a loop that will run continuously every physics frame that will basically operate the player. And it will specifically rely on this move and slide function. This is what actually moves the player. If we were to comment this out, the player would not move. They're just kind of frozen there. Poor guy. Anyway. So move and slide is necessary to actually get it working. Character body 2D is entirely controlled by velocity. You don't want to manually edit the position of a character body. You want to change the velocity towards whatever direction you're inputting. So there are a few things here like getting the input direction. So it just has this one function for getting the vector of whether you're pressing left or pressing right. And then it stores that in this direction. It's a vector too. It doesn't have the type specification, but if we wanted to, we could say as vector 2 or something. And then it gradually moves it towards whatever direction you're pushing. Excuse me. So velocity.x is move towards velocity.x direction times acceleration speed. This just basically gives it a gradual curve towards, rather than immediately being the maximum speed, it kind of brings it there gradually. But so by changing this velocity variable, which is built into character body, this move and slide function will take that and automatically move the player. So if we wanted to, we could also comment out this line, which means you're affected by gravity and you move, but you can't move left or right. You're just kind of stuck there. So this is also an important line. There's some other stuff here, a helper function. You can make whatever functions you want. There's a get new animation that's called within physics process, mostly just to break up the code a little bit. And this has a return type of a string. So by default, if you don't tell Godot what the return time is, you can just make a function, func icon type. New function, and it might do nothing. This will be a void return type. If you wanted to specifically return a type and have it be defined, you can use this little arrow and say this will return an int. If you do that, it'll get mad at you until you return a number. Also, if you want to, you can use semicolons if you're used to that. They're not going to do anything, but you don't need them. But you don't necessarily need this in order to return something. You could still say return 0, or you could say return banana. You could return whatever you want. Somebody likes return banana. Okay. You can also give it any custom parameters you want. So we could say, I'm going to call this param. We could kind of assume this is anything. So if we printed param, then say we call this in physics process. This will print every frame. This is a bad idea, by the way. But we're just going to do this for demonstration. New function, and then we're going to pass in 32. And then all this will do is print 32 every frame. The most useful function I've ever seen. Perfect. We can also give it anything else, like a string. We could give it banana to print banana every frame. And then it will do that. But we can also add a type specifier here. So we can say this is supposed to be an int. And then it will get mad at you because this is not an int. So you can kind of choose whether you want it to be statically typed or not. Generally, it's good practice to type specify whatever your parameters are, because there aren't too many situations where you'd want it to be random or independent. But if it comes up, Godot has that functionality built in. So you don't have to deal with C stuff like void pointers or whatever. It'll just kind of work out of the box. That's a little bit of function stuff. In terms of actually learning how to program GDScript, the best thing that you can do to learn this is just do it. And start messing around with stuff, read some existing code, try to edit it yourself and see what things work, what doesn't. There's also, as mentioned before, this Learn GDScript from Zero tutorial is a very cool resource. It just lets you go into here and then you can learn about 2D vectors. And there's a little lesson. You can read this. It'll give you some some things I can answer wrong and say I don't know and skip because I'm not reading it. I'm going to do that. And then it gives you these little practice sections where you can control this guy. But this failed, meaning we need to actually edit this. So why don't we say it wants us to make the scale larger. So scale plus equals vector 2. 0.2, 0.2. That's not a period. So it runs it, makes them slightly larger. Perfect. Because this is a nice little thing for just taking you through a lot of the basics. You don't need to know any prior programming. It'll just get you right into a lot of the syntax, a lot of the stuff that you need to know. And then I'm going to reset progress there. So You don't have to use this, but it's an option that's available to you, if you're, especially if you're new to programming, if you want to learn to work with Godot. But besides that, existing tutorials are very helpful. Resources that are online, looking at other files, just checking out demos like this and reading through the code and trying to figure out if you can understand what it's doing. So yeah, that's some of the basics here. So we've got about 30 minutes left. So I am just going to leave it up to you to add something to this game. It can be whatever you want, really. You can add, I don't know, a new collectible. You can make the player spin whenever they jump. You can change something to be the color red. You can go into the tile map and maybe draw some more stuff. Where is the tile map? Up at the very top here. You can make new platforms. You can make the level larger. Add more stuff. Mess around with things. See what you can do. If you want to actually create something entirely new, you can make a new scene and then make it whatever node you want. It can be a sprite. It can be a character body. It can be, I don't know, particles if you want to mess with those. Just go over here to make a new scene and then add whatever you want. And then you can instantiate it in the world through here. Things like an enemy or a player or a platform. Just mess around with things, see what you can do. All right, we'll open it up for that. And then we'll be walking around to see how things are going. If you need help, just raise your hand.